now that you've learned how to write reactions, you're actually going to learn how to distinguish between different types of reactions. And so the two that we're going to look at in this lesson are synthesis reactions and decomposition reactions. So a synthesis reaction is exactly how it sounds. You are synthesizing something, you are making it. So you're going to have two different reactants combining together to form one product. Okay, so we've got three different types of synthesis reactions you can have. You've got a 1A, and what's happening there is you have two different elements, element A and element B, and they combine together to form a compound, AB. Okay? For 1B, you have a metal oxide, so that's a metal with oxygen. So for example, you could have sodium oxide, you could have magnesium oxide, calcium oxide, aluminum oxide. It reacts with water and it forms a base. And so we'll look at what makes a base in just 1 second. And then for 1C, what you have is you have a non-metal oxide. So for example, sulfur trioxide, SO3, that is a non-metal, sulfur, and oxygen, O, and it's going to react with water to form an acid. So those are your three different types of synthesis reactions. So let's actually see what all of this means. All right, so remember, M stands for your metal, for a metal oxide, and NM stands for your non-metal. Now, for synthesis reactions, you're always going to produce one product. Now, if you're going to be forming a base, what makes a base is it is a metal and hydroxide. And so in order to write the formula for this, because this is going to be an ionic compound, you need to cross your charges. So for example, if I give you sodium hydroxide as your base, the formula would be NaOH, because sodium has a +1 charge, hydroxide has a -1 charge. If I gave you magnesium hydroxide, since magnesium has a 2+ charge and hydroxide has a 1- charge, then the formula, once you cross your charges, would be MgOH2. Okay? And then for calcium, again, because calcium is a metal with a 2+ charge, hydroxide is -1, it would be CaOH2. So those are bases. For an acid, the formula is hydrogen followed by a nonmetal, and then often followed by oxygen, not always. So for example, H2SO4, that is an acid. You've got hydrogen followed by a nonmetal, followed by oxygen. For carbonic acid, you've got hydrogen followed by your nonmetal, carbon, followed by oxygen. Now the important thing for you to know, for 1A and 1B synthesis reactions, to create your product, you're just going to cross your charges. For 1C, you're going to balance as you go.
All right, so now that we've talked about these three different reactions, let's actually look at 3 examples. So for here, I tell you iron and oxygen are reacting. I gave you this 3 here to let you know the charge of iron. Since it is a transition metal, I otherwise wouldn't know the charge of iron. That's the only reason why I put the 3 there. It doesn't represent how many irons I have, just the charge. So since I just have 2 atoms combining together, this is going to be type A. So I need to simply combine iron and oxygen together. Well, iron has a 3+ charge, oxygen has a 2- charge. So when I cross my charges, what I end up getting is Fe2O3. And the last thing I need to do is balance. So I've got 3 oxygens here, 2 here, so I'm going to put a 3 in front here. I'm going to put a 2 in front there to make them both equal to 6. That does give me 4 irons here, because 2 times 2 is 4, so I'm going to put a 4 in front here. So that's one type of synthesis reaction. Let's look at another type. For example 2, notice I've got sulfur and oxygen reacting with water. So sulfur here is a non-metal. So I've got a type C here. I've got a non-metal and oxygen. So for this one, this is always my favorite. You simply need to balance as you go. So remember, as I just noted, for an acid, you're going to have hydrogen first, and I need to balance with my subscript. And this is the only time you can do it, when you're making or breaking an acid. So I've got hydrogen, I've got 2 of them. Then I'm going to put my nonmetal next, which is sulfur. I only have 1 sulfur here. And then oxygen. Well, how many oxygens do I have? 3 + 1 is 4. So that's why acids are my favorite. You don't have to cross charges or anything, you just balance as you go, but you can only do it with acids. For example 3, I've got sodium oxide. So this is sodium is a metal. So this is going to be a type B reaction, synthesis reaction. So I'm going to make a base. So as I noted before, a base is simply going to be your metal, which is in this case is sodium, Na, with a +1 charge, crossed with hydroxide, which has a 1- charge. So when I cross my charges here, I simply get NaOH. I need to now balance. So I've got 2 sodiums here, 1 sodium here, so I'm going to put it 2 in front here. That gives me a total of 2 oxygens here. I've got 2 oxygens here, and 2 hydrogens, 2 hydrogens. I'm balanced.
Now let's look at decomposition reactions. Decomposition reactions are exactly how they sound. You have one compound, which is going to be breaking apart into other compounds. And there's a nice long list of decomposition reactions, so let's look at them. For 2A, you've got a compound breaking apart into its elements. So that's identical to what we looked at for synthesis, except it's the exact opposite. So you've got a compound breaking apart into its elements. For B, you've got a metal with carbonate, so that could be Na2CO3, MgCO3, and it's going to break apart into a metal oxide and carbon dioxide. For 2C, you've got a metal with HCO3 with bicarbonate, and it's going to break apart into a metal oxide with water and carbon dioxide. For D, you've got a metal and hydroxide, which is a base, and it's going to break apart into a metal oxide and water. That reaction we've already looked at. That is the opposite of your synthesis reaction of a metal oxide and water. For E, you've got a metal with chlorate, MClO3, and it's going to break apart into MCl and O2. And finally, if you have an acid, it's going to break apart into a nonmetal oxide and water. That's identical to your synthesis reaction. Again, just reverse. So 2A, 2D, and 2F you've already looked at. And so what I want you to do right now is I want you to highlight the compounds for which you're going to need to cross your charges. So MCO3 for 2B you should highlight, because if you're going to create that compound, you need to cross your charges. MO, highlight. MHCO3 in 2C, highlight. MO, highlight. MOH in 2D, highlight. MO, highlight. MClO3, highlight. MCl, highlight. So those are the ones that when you're trying to create the compounds, you need to cross your charges.
All right, so I just went through all 6 of these different types of decomposition reactions. Now I'm going to show you them in action. So for example 1, I have NaHCO3. So if you look at all your different options, notice this is going to be a type C. I've got a metal with hydrogen carbonate. This is a type C. So my products will be my metal, which is Na, crossed with oxygen. So I'm going to have to cross sodium, which has a +1 charge, with oxygen, which has a 2- charge. So when I cross my charges, this becomes Na2O. My other products are then going to be water and carbon dioxide, just like this shows you right here. Okay, so that's going to be my metal oxide, water, and carbon dioxide. Now I just have to balance. I've got 2 sodiums here, so I'm going to put a 2 in front here. Then I've got 2 hydrogens, 2 hydrogens. I've got 2 carbons here, which is an issue, so I'm going to put a 2 here. And then I've got 6 oxygens here. If I count my oxygens here, I've got 1, 2, and then 2 times 2 is 4, so I've got a total of 6. Right? For example 2, RaClO3 in parentheses 2. Okay? So if you look, this is chlorate here. So if you look, I have a type E reaction. So my products are going to be my metal, which is Ra, crossed with chlorine. So Ra has a 2+ charge, Cl has a 1- charge. So when I cross this, this becomes RaCl2. And my other product here is going to be oxygen. Now I just have to balance. Notice I've got 1 radium, 2 chlorines, 2 chlorines, 6 oxygens here, so I just need to put a 3 in front here. All right, for example 3, I've got just NaCl, so I just have a binary compound, 2 elements together, so it's going to be a type A. And I have to simply break apart my atoms. So sodium can exist by itself, that's cool. And my other product is going to be chlorine. Now chlorine, I can't just write it like this because chlorine is diatomic. So I'm going to have to make it Cl2, and now I need to balance. So I have 2 chlorines here, so I'm going to put a 2 here, and then 2 sodium, so I'm going to put a 2 right here. For example 4, I've got H2CO3. So since I see hydrogen in the beginning, I'm going to assume it's an acid, which it is. So I've got a type F here. Remember, this is a balance as you go problem. So what I like to do when I'm breaking up my acid is I like to write water first, and then my other product is going to be a non-metal oxide. So my non-metal here is my carbon, and then to figure out how many oxygens I have, I need to balance as I go. So I've already used 1 oxygen here, and I need a total of 3. So this is going to be 2 oxygens. The other way to do this is if you just do it in reverse, right? Just to check yourself. If this were a synthesis reaction and I had a non-metal oxide and water reacting together, that would then form an acid. And remember, you would balance as you go. You put your hydrogen first, so I've got H2, then your non-metal, C, and then you'd add your oxygens together, 3, so O3, which is what I have. So that's just a nice way to be able to check yourself. In D, I've got lithium hydroxide, so this is going to be a metal hydroxide problem, so that's going to be a type D. All right. So my products will be a metal oxide and water. Well, my metal here is lithium, which has a +1 charge, and oxygen, which has a 2- charge. So when I cross my charges, I get Li2O. And my other product is going to be water, so H2O. All right, now I need to balance. I've got 1 lithium here, 2 lithiums here, so I got to put a 2 here. I've got 2 oxygens here, 2 oxygens here, and then 2 hydrogens, 2 hydrogens. I'm good to go. All right, for example 6, beryllium carbonate. So I got to find my reaction with carbonate. It's right there, a metal carbonate. So my products are going to be a metal oxide and water. Well, my metal in this case is beryllium, so it's going to have a 2+ charge. And then I have oxygen. So when I cross my charges, that becomes Be2O2. But remember, you can simplify, and you need to simplify it, so it just becomes BeO. And then carbon dioxide is your other product. Okay? And so this was a type B. So I've got 1 beryllium, 1 beryllium, 1 carbon, 1 carbon. 1 + 2 is 3 oxygens, and I am balanced. So I have now shown you all 6 different types of decomposition reactions you could possibly see.